Good afternoon again, my viewers. Today we are looking at the topic ethers. Okay, you are familiar with functional groups, and you are familiar with terms such as functional groups, homologous series, etc. So ethers are a particular class of homologous series, which are usually represented like this: ROR. So O is the oxygen, and on both sides of the oxygen, you have an alkyl group or an aryl group, as the case may be, attached. Okay, so this is what you have different types. You have the symmetrical ethers, and you have the unsymmetrical ethers. In the symmetrical ethers, the alkyl group and the alkyl group here are the same. So if I make this R prime and then this one R, so that means R prime and R are the same for symmetrical, and for unsymmetrical, R prime and R are different. Okay, that's about the types. So very quickly, how are ethers prepared? Preparation. I want this to be as short as possible because it's introductory, and I want you to also know that it is not that long. Just pick the main content and be able to expand it on your own using your personal reading program. So the first method of preparation is by the dehydration of alkanols. Okay, so you do this by heating alkanols or an alcohol with concentrated H2SO4 at 140 degrees Celsius. So if I have C2H5OH, okay, if I heat it to a higher temperature, say like 170 degrees Celsius, you will, and that is 443 Kelvin, I will get a total dehydration. That's, you get an alkene. That's what most people use this kind of reaction to do. Just dehydrate, remove OH and H, and you have an alkene there. And that is, of course, in the presence of Kong H2SO4. But if you have an excess of alcohol, so excess alcohol, so if it is excess alcohol or alkanol, okay, with Kong H2SO4 at the 140 degrees Celsius, which is 413 Kelvin, if it's like that, you will have C2H5O and C2H5. So you have the ether formed if you regulate the temperature this way, and so that's one way of obtaining obtaining ethers. Another way of obtaining ether, number two, is by passing alcohol, or let me use the word alkanol vapors over hot Al2O3 activated at 250 degrees Celsius. So that would mean that you have your ethanol here. That's ethanol gaseous. Gaseous means vapor, right? Okay, and you have two of the molecules. You have alumina Okay, that's Al2O3. And at 250 degrees Celsius, then you have your ether. Okay, which kind of ether is this, if I may ask you, Jesse? Which kind of ether is this? Is it symmetrical or unsymmetrical?
It's symmetrical
Symmetrical. Why?
because the the hydrocarbons on either
The
side
alkyl group
side
on either
the alkyl
sides are
groups
the
are
same.
identical.
Thank you. The same. Okay. All right. So number three in the methods of preparation of ethers is the Williamson ether synthesis. Okay. And Williamson ether synthesis begins with a reaction between sodium hydride and an alkanol. So I'll just do a general reaction here. So if I have an alkanol, ROH, okay, so it begins with a reaction of sodium hydride, which acts as a base. Okay, so that would first of all lead to the formation of RO, okay, minus. Okay, so uh, this is an alkoxide ion. Okay, so the alkoxide ion will now afterwards attack a haloalkane or an alkyl halide, such as um, say R prime Cl. Okay, so that R prime Cl. Let me just put it that way. Okay, so this will attack. Okay, I'm going to show you clearer in a specific example very shortly, and then this one will fold up and go away. So what you will end up having will be R O, then what's the R prime. Okay, so whatever is the alkyl group attached to the alkyl halide, hmm, and the alkyl group attached to the OH in alkanol, both of them will now be on either sides of the oxygen, and you have your alkyl, you have your ether already synthesized. So I'll just use a specific example now. So if I used methanol, if I use methanol rather, OH, I will bring NaH to form them. If this is methanol, what will be the name of the alkoxide? The alkoxide will be what? The alkoxide will be methoxide. Is that okay?
Yes.
Minus, right?
Yes.
Okay, so if I now bring ethanol to the side, CH3, CH2, Cl. Okay, so what will happen is that you know that this part, this CH is already delta what? Positive, right? Since it's the one connected to Cl, and Cl is delta negative, right?
Yes.
Okay, so this will attack this positive, right?
Yes.
Are you with me?
Yes.
As it's attacking, this one will fold up, right?
Yes.
Why is it folding up? Because there is already, you at that point you'll be having 5 bonds around carbon. So it will fold up and go away. So what would you have eventually? You have CH3O, and then you start from here, CH2 and what? CH3. Okay. So you, in that case, now you now have what you call, this is, you have CH3 on one side, you have ethyl on one side. So what would be the name of this ether that has been formed?
It's going to be
You can say ethyl,
methyl
methyl,
ether.
ether, right?
Yes.
And you can also say methoxyethane, right?
Yes.
Like methoxy is hanging on and ethane. Is okay?
Yes.
All right. I hope that is simple enough. Okay. There are some other things to take into consideration when you are doing these. For example, um, if you are doing this, I'll leave this, since this is a kind of tutorial interaction. I'll leave this for you to think about. If I have this compound, what do I need as reactants? What are the reactants? Reactants. What are the reactants that can be used to obtain this compound? What's the name of this compound? Third butyl methyl
Ether.
ether. Okay, so I'd like you to play along with that. Okay, so particularly I'm saying what are the reactants, and the reactants will be an alkanol. Which one is the alkanol, and which one is the alkyl halide? Is okay. So you have to find that one out. Okay. I think I remember that I didn't dwell on the nomenclature. I didn't dwell on the nomenclature, and it's important that we talk about it. Okay, nomenclature of this. So if I have this, what does that mean? If I have this, what does that mean? If I have this, what does that mean? If I have this, okay, so can I start from here? So this is methyl and methyl. So you call this dimethyl
Ether.
ether. What about this? You have methyl on this side, you have 1, 2, 3 propyl on this side. So you say methyl propyl
Ether.
ether. This is phenyl group. You know, when you have benzene ring here, you call it phenyl group and an ethyl group. So you say ethyl
Phenyl.
phenyl.
Ether.
Come on. Ethyl phenyl ether. Okay, and then this you have this is cyclohexyl. So you say you have cyclohexyl ethyl
Ether.
ether. Okay, so I hope this helps you to understand uh, what we're talking about. So very quickly before we round up, the physical properties of ethers. Of course, number one, they are colorless. They are colorless. Number two, they have lower boiling points compared compared to compared to their corresponding alkanol. Number three, they are highly flammable. That particularly the simple ones, the small ones, diethyl ether, all those smaller ones, they are highly flammable. And because of the combination of this one and two, it leads to one use. They are used as solvents in chemical laboratories. In fact, they are excellent. They are excellent solvents. Okay, are we together?
Yes, sir.
Are we together?
Yes, sir.
So I've already started talking about application. I've already started talking about application. Okay, so number one, they are excellent solvents. Solvents for fats, oils, waxes, etc. They are used to they are used as disinfectants. Well, some of them used as what?
Disinfectants.
Disinfectants. Some specific ones we can just say, okay, for example, diethyl ether has been used as a general anesthesia during surgery. And then it has also been used in diethyl ether again is used in Grignard reaction. Okay, so at this point, I would like to stop and um, expect you to just broaden your reading as you prepare for um, tests, exams, and things like that. So, thank you so much for listening and for watching, and see you in our next video.